So I'm Loren Larsen, I'm the CTO at HireVue, and I was kind of asked to talk about AI and machine learning. We've been doing that at HireVue for a while. So I thought about what could be useful to this group. First, I guess I'd love to know just, we've already prepared slides that have talked, but it'd be good to know just kind of what experience people have with AI. Like who in the room has kind of done a lot of machine learning, a lot of AI, just by raising hands, or feel really comfortable with it? How many people are actually interested in it but haven't done it? Okay, so most of the room is at least interested in the topic. Okay, so, and then how many people have heard of HireVue? How many people have actually taken a HireVue? Okay, a few people? Okay. For those who don't know what HireVue is, I'll talk about that in a minute. But basically, HireVue is a company that has been interviewing people on video. And we've interviewed about 12 million people, and about 6 years ago we started using AI to predict who'd be good at a job. So I'm going to come to that in a minute. I wanted to just brainstorm what are some uses of AI today. Handwriting, real estate, image recognition. If you've ever taken any AI course online, you've probably looked at those. People are using them to play games. Then you start to get into things like facial recognition. You're walking down the street, it knows who you are, it knows where you're going. Loan applications. Who should stay in jail is a really interesting one. Guiding sentencing guidelines. Self-driving cars and drones, and job performance, which is what HireVue focuses on. So the important thing I think about this slide is just these last few categories are things that are really important to people's lives. The decisions that are being made by algorithms are incredibly important. So my talk's going to talk a fair bit about kind of what we've learned at HireVue about making decisions about jobs, who should get a job, who should be best in a job. And it's a really, really important decision. If somebody gets that job, they get that shot that they might not have otherwise had, it could change their lives. We've had people interview from, literally you see a video of somebody interviewing for a job in front of a grass shack in Africa. And what that probably means is they live in a grass shack in Africa, and it's the first time that they've had a chance to get a high-paying job with an oil company that's going to let them have enough money to send their kids to school. So it's important that this stuff works and it be correct. So let me talk a little bit about the context of HR. I never thought I'd work in HR. There were a couple of things I never thought I'd work in. Games, HR, insurance, HR. Here I am. I've been working in it for 8 years. But what typically happens for a candidate is you apply, you create a resume, you write a cover letter, you send it in, something processes it, a human, something like that, and then it goes into a black hole and you never hear back. And you wonder, like, what happened? And then 6 months later, like, oh, we didn't have a role for you, thanks for applying. And that's a really terrible experience for anybody to go through, but that's kind of what's happening today. But the problem is that HR departments are just inundated, typically, with candidates. They're not really inundated with candidates, but they're so busy trying to find anybody at all who will apply, because they have like 100 jobs they're trying to fill, they don't actually have time to actually process all the things that are coming in. So there's a huge volume problem. We work with customers who literally, like Delta Airlines will hire 2,000 flight attendants a year. 200,000 people apply to be a flight attendant at Delta every single year now. So they've just got this volume problem. How do they look at 200,000 people? How do they find the needle in the haystack? You can't do that with a human process. And the very best person for the job might be the 200,000th person that applied. Or it could be the first person in the middle. You just have no idea where that person is. So this seems like an area that's really useful for an algorithm to help with. So how does HireVue help with that? HireVue has been around about 15 years. We originally developed what's called an on-demand job interview, which is a one-way interview, where somebody is invited to take an interview, they click a link, they open an app, or they open a website on their computer. They're presented with a set of questions. You're asked question 1, you respond on video, you go to question 2, you respond on video, all the way through, and then that's been recorded, it's been uploaded. The hiring manager or recruiter gets it linked to that, and then they watch you and decide if you're a good candidate or a bad candidate. So why is that a good idea? It seems like a very impersonal process. It seems like, why don't they just call you? The challenge is they can't call everybody. They're going to make a decision off of a resume. Which means that when somebody applies for a job, the first thing you're evaluating them on is their resume writing skills, which is not actually a job qualification. We have a number of customers who will tell you, especially with certain populations like people on the autism spectrum, oftentimes the worst resume is the best candidate. You just can't predict that much from a resume. And so they're making a decision about a resume, and they're saying, okay, well, I have time to phone screen maybe 10 candidates. And if there are 100 people apply, 90 people didn't even give a chance. They just got rejected off this resume. So what HireVue sort of let people do was, I'm not going to worry about the resume. I know it's not a great predictor. For somebody who just graduated from college, they all kind of look the same. There's not a lot on there. So they just invite everybody to take a HireVue. And then everybody gets a chance to sort of tell their story, describe who they are, what they're about, what they want to do. And then they can go through the HireVues. It takes longer to reject someone from a HireVue than from a resume, but everyone's had a chance to be seen, to tell their story. It lets people interview who wouldn't otherwise have a chance. They work late night shift, they're in a different location. Goldman Sachs used to go to 200 schools. Now they don't go to any schools, and they interview at over 1,000 schools. So that person in New Mexico State, who would never have got a chance to work at Goldman Sachs, but they're really, really good at finance, now has a chance to work at Goldman Sachs. And what that also tends to do is increase diversity. So it increases ethnic and racial diversity, because they're going to schools that they don't normally go to. They used to go to Harvard, they used to go to Yale, they used to go to Princeton. It increases gender diversity. So we think this is a really important thing to be doing, and it's fundamentally changed the way that hiring gets done. So this picture here, I'll just allude to a little bit. This is an interview series that we do for software developers, which is you answer a couple questions on video, you play a couple of games. We've introduced cognitive games to measure thinking ability, problem solving, etc., which are kind of fun and engaging. And then you can have a coding test. So this is just one way that you can sort of look at a broad range of abilities for a software developer. If you're hiring salespeople, it might be 2 games and 5 video questions that measure different competencies. Does that make sense? All right, so this is a resume. I just want to highlight a couple things about resumes. So we've got James Smith is the name. If that name were Sanjeev Gupta, or it was Xinhu from China, that person, the same resume with a different name can be anywhere from 2x to 3x to 10x difference in response rate. So someone who's Chinese might change their name and send the same resume out, and they'll get 10 times the responses than they would if it was their Chinese name. So this slide is kind of about the biases that we build up as humans in looking at something. Because a recruiter's sitting there, got 100 resumes, how am I possibly going to make a decision? We come up with shorthands. So we come up with where they work class, what school they went to, what their GPA is, maybe what their address is, and then we put it into Google Maps and look and see if the yard looks nice, or if it's a big house or a small house, we make decisions about it. Are any of those things related if somebody's good at a job or not? Probably not. Google's done a ton of study on GPA and school and all of that. So we know that there's a huge amount of bias inside of a resume to start out with. We know there's gender bias. We know that there's racial bias. We know that we look for people that are similar to us. I was talking to somebody at one of the major banks, and he said, can you tell if one of my recruiters only picks people who like lacrosse players? Because you play college lacrosse, anybody who comes in to play lacrosse, they're good people. Not a good way to pick people necessarily. We have lots of age bias. We just can't really seem to get over that as people. So really quickly, I won't read this whole slide, but the main point here is when we apply video, we've been doing this for 15 years, more people get included, people are treated more fairly, especially when we apply AI, and I'll talk about how we do the AI in a second. We've seen customers get a 16 to 25% increase in diversity. When you can automate the process, and so if somebody takes an interview and you can immediately score them with AI, you can shorten your time to fill a job role from one customer shorted from 55 days to 7 days, which means they have sales roles that were sitting empty that are now filled. So now they're selling more stuff. So it's really, from a business perspective, they're making more money, they're filling roles, they're spending less time on each role. The best candidates also leave because they got another job. If you take 60 days to fill a role, the company that can fill it in 5 days gets the good people and you get whoever's left. So they get better quality of the people that they get. So that's kind of what we've been about, and really great results. So it's a problem worth solving, is my main point. But how do we overcome bias in the process? You can train people about bias. Diversity training doesn't seem to work. Sometimes it actually makes the situation worse. The truth is people have no idea what to actually look for. So when I think about what HireVue is doing, we've got a video of somebody answering a question about something that's related to the job. We want to look at everything that's in that. What did they say? How did they say it? And we want to build a prediction of, based on what they said in an interview, are they likely to be a good hire or a bad hire? So, yeah, so we're going to look at all the things that are in there, what they say. But what are we looking for? So you have to come up with some kind of success criteria. Like, what does good look like? In salespeople, it's fairly easy, right? You can say, did they hit quota? If it's in a call center, it's, did they handle the calls quickly? Do customers tend to like them? Do they answer the customer's issue on the first call? Those are fairly interesting, easy metrics. How do you evaluate software engineers? We're all awesome, right? Just ask us. It's harder. There's definitely job roles where it's fairly hard to figure out like what is good. But if you make an effort at that, you're probably a lot further ahead than just the arbitrary hiring processes that most people have. So we always work with the customers to figure out like, what does success look like. We identify like, what are the skills and abilities you need to predict that. So you ask questions that get at that. And then you've got this data set of people who are answering the questions. And then you sort of build a model. So you go at the customer and say, okay, you've interviewed 1,000 people using this model. You've decided that 500 you didn't hire. You hired 500, and 100 were great and 400 were mediocre. So let's build a model that finds more of the 100 people that are great, so that when the next interviews come in, we can just tell you, go after those 100 first. You can reject these 500, and the 400 in the middle, like maybe you need to look at more closely. Does that make sense? So that's really what we're trying to do, is take this interview data and predict job performance. And the idea is you get 500 people in, they kind of come in any order, but when you look at that list of 500, we want to push all of the best people to the very top of the list. So your recruiters just kind of work down the list, and they're always working off the very best people they can spend their time with. And in a way that's it feels like an impersonal process at some level, and I think it's important when we think about AI and automation that we think about like what's the impact on people, and is that positive or not? So I think my goal for this talk, honestly, is not necessarily to teach you about AI, but to give you a set of questions that you can think about where you want to apply AI. And I think we learned some really interesting lessons about that. Does this make it more impersonal or less personal? So if you were the person who applied, and you were one of the 10 people that got the phone interview, you'd be like, I would just prefer to have a phone interview, I would prefer to interact with a person. If you were one of the 90 people that just got sent into the black hole and never heard, would you prefer to get a chance to tell your story and be seen? Like, which is better? It depends. Like, if you just have 100 opportunities and it's a waste of your time to go after that opportunity, maybe it's a waste of your time. But if you really want that job, if you were 11th on that list, taking that phone interview is a great opportunity. The video interview is a great opportunity for you. And then the humans can spend their time with the most promising candidates rather than trying to spend just a little bit of time with a few people. So we think it's a really good benefit, even though at some level it feels impersonal, it ends up in some ways being much more personal. So I wanted to share 4 lessons that we've learned in general as we've applied AI. So I hope that sets up the problem fairly well. So there's a lot of story out in the press about algorithms being biased. And they just propagate human bias. So if you have bias in your hiring, you just automate with an algorithm, you'll just have more bias. Does that sound right?
Yeah, bias is testing your metrics on success.
Yeah, so if you have bias in your performance data, for example, you say, okay, well, we have half male, half female people, but all of our top performers are male, that could end up being biased, right? So let's talk a little bit about algorithms and where they failed. So one example is policing feedback loops. I don't know if people are familiar with this idea. It's basically, you look at a bunch of data, and it tells you where crime gets committed, so you send the police to that area. So the police go to that area, well, they're there, they're probably going to arrest people. It might be for minor crimes, but they're there, so they're going to arrest more people there. So the next time you look at the data, you're like, whoa, crime's getting worse there. We keep arresting more and more people. But it's because the police spent more and more time there because the algorithm told them to. So it gets this negative feedback loop where one area continues to get more and more attention, more and more crime, which, et cetera. So that's a place where the algorithm can kind of lead to a bad result. There's this idea that came out from Google about Google image classification, where they trained video to recognize different animals. You put in certain faces and it says that they're animals. That's kind of a problem. That's kind of an unsupervised algorithm just running and no one going like, actually that's not correct. But what's been interesting is a lot of companies have just put models out there and they're not watching, they're not checking. And then some media person finds it and checks it, or somebody in the public checks it. It's really, really important when you deploy these algorithms that you're checking the outputs. Another example here is there's been some really well-known work about cameras doing facial recognition, or just recognizing a face. It's much better at recognizing white faces than African Americans. Did they test that? Not really. And you think, well, why didn't they test it? Like, honestly, just no one thought about it. It wasn't because someone didn't care. Well, they didn't care enough to think about it, but they just didn't know. I don't know. They just didn't think about it. There's a famous training set on this from NIST, which is a government agency. Within that training set, there's only 5% women of color in. Well, it's very likely if you only have 5% women of color in your training set, you're not actually going to find any women of color when you actually run the algorithm. You're going to be pretty poor at that. So it's really important when you think about a training set, you sort of think about what the edges are, what the makeup of it is. It's really been stunning how many vendors we've seen just don't think about it. And they don't test it. And when you ask them, they're like, I have no idea what the makeup of our training set is. And that's really problematic. Amazon got burned on that. They were making hiring decisions based on resume prediction. Turns out most of the resumes were from men because they were software developers, and that just kind of reflected a propagated bias. But they didn't test it. They didn't look at the mix of their training set. They kind of just got busted in the middle of the project, and they're like, something seems wrong about this. So it's really important to test up front. This is another one. It's famous kind of Microsoft Twitter bot. This bot out there. I'm sure most people have heard about this. And then people decided to teach it bad things. Like, you're a 4-year-old, you start teaching it. You're like, where did you learn that? Very easy for people to pick things up. And we all pick things up. But as humans, we kind of like, maybe I shouldn't be doing that. And kind of pick up a bad habit from so-and-so. A bot has no idea. It just keeps propagating whatever it's being exposed to. So the main point here is we have to be really, really careful about bias. But it's not one more example. So this is an example I mentioned earlier about who goes to jail. I won't spend a lot of time on it. You can Google it. It's fascinating. It's a compass model from ProPublica did a big study on this. And the guys who started Compass, like PhD in statistics, was trying to prevent crime, very well intentioned, but then judges started using it in sentencing guidance. And it turns out that it's much more likely to recommend that an African American is likely to commit a violent crime, even when they're not. So in other words, even when it's wrong, so for people who it recommends would commit a violent crime who actually don't, they're much more likely to be wrong about African Americans. There's a whole bunch of other things that they're wrong about. You can go read about it. But again, like, they didn't test that. So, like, making sure your training set is thoughtful, and that you're testing for all of these kinds of bias are really, really important. I won't belabor this whole point. So let's go back to HireVue and hiring. So what are the things that we're required to not do in hiring? So in hiring in the United States, there's protected classes. We can't discriminate against people on gender. We can't discriminate on ethnicity, age, disability, etc. And there's something called the 4/5 rule, which says if you have a group of people who, let's say 80% of whites get hired, well, you can't be, no other, if that's the highest passing group, no other groups can be further away than 80% of that, essentially. So if African Americans are 40%, well, there's twice the passing rate for whites than blacks. That's a big problem. So the EEOC will come knocking on your door, and you'll have a lawsuit and penalties. So any hiring process, whether it's algorithmic or not, has to comply with this. And if you're failing the 4/5 rule, this is the general standard that you should be following. So I have a fair bit of time. I'm happy to take questions as we go if something doesn't make sense. So if you've got something, please these ads. So anytime we're building an algorithm, we have to make sure that when we're presenting a score about a candidate, that we're making sure that the passing rate of any group is within 4/5 of any other group. Make sense? So that's kind of how it applies to hiring. And at HireVue, we've been really methodical about that from the very beginning, fortunately. What's interesting is we can get data from the candidates, or we can predict it from video. So we build predictive models that from the video will predict age, gender, ethnicity, for example. And then we can use those classifications. They're not perfect. No predictive algorithm is 100% perfect that I know of. But they're statistically close enough that we can say, yeah, it looks like we have 1,000 candidates here. We generally know what their age, gender, ethnicity is. The algorithm looks like it's making valid predictions. So I'll talk about in just a second how that works. So we're going to take all of the text, audio, and video. We're going to build an algorithm that predicts this business metric or competency that we're trying to figure out, like, do they hit sales quota? We also want to find out if that same algorithm can predict the gender or the age or the ethnicity of the candidate. If that algorithm can predict one of those things, then you probably don't have a completely bias-free algorithm. Does that make sense? So sometimes you train something and you go, oh, it predicts performance. But if it's just all the males that are getting good performance, you don't know if you're actually just predicting gender or if you're predicting job performance. So you really want to have something that can't predict, is blind to gender, age, ethnicity, or the other protected classes, but actually predicts performance. So you have to test these things. And it's really a pain, actually. It's a lot of work. It's really easy to come up with an algorithm off the internet, you get some data, you've got, oh, I predict something. But you've got to test against the groups and think about how does this recommendation affect different groups of people. And it's really, really hard. So then what we can do is we can find there's certain features. If the algorithm does have a bias towards a group, we can identify there's certain features that contribute to that. So if we're looking at, say, one of the things that we look at is like pronoun usage, just as an example. Like, do I say I a lot, I, or do I say we? You probably noticed that in interviews sometimes people only talk about the team and the group, and other people just talk about themselves. So that might be predictive, it might not be predictive of different things. If that's contributing to the gender prediction, then that's useful to know. So here's an algorithm that we use. Here's just an example data set of things that we might be looking at in the algorithm. So we might look, do they smile? Do they use words related to emotion? Do they use words related to their cognitive state, like depressed, upset? Technical language. So if you're looking for doctors, they might use words that refer to like medical terms, like I prefer my doctors to know the medical words, it turns out. They're better doctors, it also turns out. There's words about power and control that people will use. We have 13,000 features on this model. So you take all the different words that have been used, all the different categories of words, metadata about how they use verbs and pronouns and prepositions, how they use that. There's 13,000 things. So what we're seeing here is, on this left side, you can see this has an impact. Notice that no particular feature has that much impact on the overall prediction because there's so many features. But we can also figure out which of those contribute to the gender bias. So, is that a question?
Yeah. So when you say features, are you talking about combinatorics on the smile? Or are you talking about 14,000? We're only seeing 7.
So, just for the sake of description, it would say this person smiled a lot or they didn't smile a lot. They were smiley or they were not smiley. And you can get much more, without getting too deep into it, like you might want to know, like, they smiled when they said the word murder. That could be concerning. But they frowned when they said the word murder, like it might indicate something different. But let's just in general, like you're going to generate a set of features from an interview, and you're going to put it into a neural network, for example, and you're going to try to predict whether they have top performer or bottom performer. The feature might be high smile, low smile, or 0 to 100 score, or how many times they smiled, something like that. Is there a question then? Okay. So what I'm trying to say is that certain features contribute to the predictive value, and certain features contribute to the prediction of a gender class, the gender class. Okay. So what would we do in this case to get rid of the bias? We want to get rid of the bias. We don't want our algorithm doing that. We need to get rid of those features. We get rid of the features that are high on the impact of bias, but like they have some impact on the performance. But I've got 13,000 features. So what turns out to be true is the old algorithm. I didn't get into this sort of math of the adverse impact ratio was 0.67, which is below 0.8, the 4/5 rule. But the R value, which is the predictive value of this algorithm, 0.42. If we strip out those features, it could go to an adverse impact ratio of 0.94, which is great. It's above the 0.8. But we didn't lose that much in the predictive value of the 0.4. Does that make sense? So you can start to play with which features are helpful, which features are not helpful. And you need to look at the features and go, like if the feature was facial luminance, like how much does a light reflect off the face, you're like, yeah, I can conceptually understand how that might contribute to bias against a certain class. Does that make sense? So these are things you can play with around mitigating bias. So we also have worked on something called attractiveness bias, which seems like, why would you look at attractiveness in the HR context? It's not a protected class. Being ugly is not going to help you get a job. But there are actually countries that want to score attractiveness. They want to say, we only want people that look like X. We don't do that, by the way. We will not help with that. But what we were interested in is, one, does attractiveness contribute to whether somebody gets a job or not? And then, does an algorithm propagate that bias? Does that make sense? So we took a data, so we built an attractiveness model. Actually, our friend Ben Taylor at Ziff, I'll give him credit, built the model. We worked on it with him, and I worked on it with him, but he built it, and we said, could we use it? But the algorithm basically takes pictures from the internet and ratings of people from the internet from sites that you can look at. And it will build a predictive model on how people would rate an image or a person based on that image. You can see Ray finds apparently the most attractive man that ever lived. And being a politician does not require much on the attractiveness side. Yeah, so we built a model that can predict that. You can kind of predict anything from an image if you work at it. And I think there's one interesting lesson in this. So Ben Taylor used to work for me and work with us at HireVue. He was our chief data scientist, and like HireVue's always had this idea of like, oh, we can just build that. And there are a lot of things in the AI space that you can just build a model for. There's a lot of algorithms out there. The algorithms are not the hard part. The data set is the hard part. And there's a lot of free data out there that you can scrape. This was scraped from an API. Just wrote a script, scraped the data, put it in the model, built the model. And Ben is amazing at saying, oh, we can just build that. But he follows the word tonight. We can just build that tonight. The next day, he's like, I built an attractiveness model last night. If you're thinking about these kinds of problems, there is probably a data set out there that you can use. And then I'm also going to say, like, getting the data is really, really hard. Getting good performance data is incredibly hard. And I'll talk more about that in a minute. But coming back to attractiveness, we built this model that can look at attractiveness. And then we looked at, because we have rating data from people, we have who got hired data from people. We wanted to find out, like, do people who are rated highest, are they also the most attractive on this rating scale? Does that make sense? What do you think happened? Did more attractive people get hired more readily? I see a nod. Yes, that's true. So this was a retail brand that we did this particular study on. If you were rated a 7, it was a 0 to 10 scale that we actually used for the study. You were twice as likely to get hired if you were rated a 7 than a 3. Like, that seems horrible. Like, the hiring process today is so biased in so many ways. Like, I would never have believed it until I kind of got into it, but we would come up with these biases, we go with shorthand rules, we interview people we don't know what to ask, we don't know what success actually looks like, we don't know what answer that they could give that would actually predict success, and we're usually thinking of something else when they're doing something. Like, that's not a good process. Like, this process should be improved by a machine. And again, somebody walks in and they're going to be evaluated on how much the interviewer, how attractive the interviewer thinks they are. It just seems wrong. So, I left out a slide, but what it turns out, so then we build a predictive model that says, let's look at performance data, and let's look at the interviews these people took, and let's see if the algorithm that predicts performance also prefers people that are attractive. So what do we think happened? Well, turns out the algorithm doesn't care at all. It's not looking for that. It's only noticing for the things, the features that are going in that actually predict performance. So this was a really kind of exciting result when people think, oh, we just propagate bias with these algorithms. It's like, no. If we train the algorithm on the thing that actually matters, we can eliminate some of the human biases that are sort of plaguing the hiring process. So I think that's super cool. So a couple of just best practices around AI for hiring, that apply to a lot of other things. You really want to understand and control what features go into the model. So don't use facial luminance. Like, it just isn't a good idea. So think about the features going in. Don't use attractiveness, for example. That's probably not a good idea either. You had an attractiveness feature. So strive to use features that are not tightly tied to class, like I just said, facial luminance. Strive to make sure your algorithm is blind to these classes. In fact, the other piece is, once you launch a model, even if you tested it, it may not actually behave the way you think it did in testing. So it's really helpful to sort of continually monitor. And so because we can look at every video that comes in and make a prediction about age, gender, ethnicity, we can then also see, is our scoring behaving in the way that we expected it to? And all kinds of things can happen in the hiring process after the fact. Like, they can start sourcing from different schools, different places. They can hire a new head of recruiting who gives different instructions to the recruiters about what resumes to flow through. They can stop interviewing everybody and only interview like a certain group of people. And that would change the way the algorithm works. So the algorithms aren't like static. They don't just sit there and they behave the same way. They're influenced by all kinds of things. They're influencing inputs. Okay, so lesson 2 is getting data is hard. And it's easy. So like I said earlier, like Ben Taylor, who runs SIF, is amazing at just being like, oh yeah, I went out and pulled this data set from here, and I built this model last night, and look, it's amazing. That's surprisingly easy to do sometimes. But sometimes it's really, really hard to get good data. I'll give 2 examples. One is performance data. How do I get, for us, we need about 300 to 400 examples of interviews that are with a performance target. In other words, I need to know 400 interviews, and I need to know that these 200 were good and these 200 were bad. Well, okay, that's actually hard to get. Go into a company and say, can you give me 400 interviews? They're like, well, I only did 300 last year. Like, oh, I'm not going to build a model for you. That's really tough. Or they say, well, we only hire 5% of the people. So if we're going to use the hiring decision, now I have a very imbalanced data set. I don't have like half are good, half are bad. I have 40 were good and 360 were bad. That's not a good way to build a model. You really want to have some balance in your label set. So you have to think about that. Just having it set, oh, I've got 400 examples. It's not balanced in the right way. And then you have to sort of consider, like, is the performance data any good, right? If it's just like, if it's like, did the manager like the person, or did they like going to lunch with the person, that can be super random, and you'll never find, you can't predict something, there's no pattern to it, right? Or we're just predicting who somebody likes, which isn't actually a good thing to do. So these are all the kinds of things we have to think about. Another example of a really hard data set is we made a dubious decision to build our own speech-to-text model. So we've got all these interviews, I've got this audio, we have to pay 60 cents to $1.50 to get that transcribed into text so that we can run language models on it. That would be a great idea to build our own speech-to-text model. Well, that's a terrible idea. It's like the worst thing. Because where do you get tens of thousands of hours of audio with an accurate transcript that's lined up in the right time sequence that you can build a predictive model? That's an incredibly hard data set to get. You go, oh, let's just use let's just use, we'll get a bunch of DVDs, we'll rip those, and we'll use the subtitles. Subtitles are terrible. They very rarely match what's actually spoken. They're very often off time sequence-wise. It's a terrible idea. Oh, YouTube has transcripts. Let's use those. They're terrible. So it's just really hard to get good data sets sometimes, and before you sort of tackle the problem, it's good to think like, oh, that's easy, that's hard. But generally speaking, I would say lean into it and figure it out. We were able to build ethnicity, gender, age models really quite quickly. So getting good data can be hard. Just be aware of that. Oh yeah, let's do this. Yeah, like this is just a simple example of like, this is the number of samples we need to build a model. So if we have like 1,000 or more examples, like with Delta Airlines, we built a model for hiring flight attendants. We have hundreds of thousands of examples. It's a huge model. And we have really, really good predictive value over here. We're really happy with compared to any other method for predicting job hiring. We can build models between 300 to 500 samples. Sometimes we can go lower, but the AUCs can be a lot lower. So you gotta kind of decide, like, do you have enough data to get an acceptable level of predictive value? Lesson 3, I trust AI more than you, but not me. This has been a really interesting one when you think about a recruiter. The recruiter will see a video and they'll see a score. And they'll watch the video and be like, I love that person. The algorithm said they're terrible. People are actually pretty willing to accept AI for a lot of things in a prediction. We do it all the time without even realizing it. But if I can compare my opinion to the algorithm, people will almost always trust themselves. And I trust the algorithm more than you, but not me. And that's really quite fascinating. So we've had to learn a lot about how we present data to people. We also will see people get stuck in, so this is probably hard to see, but this is kind of a percentile rank of your candidates with like 93, 78, 74. You can bucket them into tiers and say, this is a good candidate, mediocre, terrible. People are pretty willing to accept that, but if you show them a 74 and a 78, they'll look at the person who's a 74 and the 78 and think, I think Esmeralda's better than Mark, so I think the algorithm will crash. You're like, well, I mean, 74, 78, like, it's not that precise. But if you represent it as being precise, when it's not actually that precise, then people will start to doubt the effectiveness of the algorithm. So that's something we've had to deal with, which I think is something you have to think about quite a lot. And then lesson 4 is people want an explanation without it necessarily helping them. So we originally were doing this thing where we're giving percentile ranks of candidates, saying like, look, just go down the list, watch the people in the order we gave them to you. Like, yeah, but why is Esmeralda 74? We're like, well, it's really hard to explain. There's like 13,000 features, and you have to understand the weighting of them. And people want to know, like, but I just want to know if they're like friendly. And you're like, well, you gotta understand there's 13,000 features. But because, like, as humans, we want to like, no, I just want to know, like, is friendliness the most important thing? I'm like, well, I mean, it's kind of complicated because it's not just about friendliness, it's about all these other things. But people are like, no, I just want to know if they're friendly. And then if you tell them that they're friendly, they're like, I knew it was friendly, so I'm just going to look for friendly people. Like, it's more complicated than that, I'm serious. So people really want an explanation. We've had to prepare results that kind of break down, I probably can't read this from here, sorry. But there's basically competencies that we're predicting individually. So we will score the person on communication, their personal stability, level of conscientiousness, problem solving. There's 14 or 15 things we might score them on. And the worry there is they feel good because they're like, oh, I get it now. But then the concern is now they're going to be like, I knew it was about personal stability, and they're only going to look at that thing and predict people who are based on personal stability. So you have to be really careful when you kind of do the explanation of why the algorithm comes up with its score. You actually introduce the ability for someone to use that data in a way that probably isn't actually helpful. So that's kind of what's And since it's about mobile, I'll say in a minute. There's a bunch of talks on mobile today. We've been building mobile apps we've had mobile apps for both recruiters to watch and candidates to take the interviews for about 8 years. We started with sort of everything was a native app. iOS, Android, we had 2 people. We ended up with 8 apps at one point for just different variations of things. With 1 Android developer, 1 iOS developer. Last year, early last year, we switched to React Native and rebuilt our candidate app in React Native, and we're just launching our recruiter app in React Native now. And that's been fantastic. There's been sort of no downsides from my perspective. The team's been really happy. Both developers can contribute to sort of a common code base instead of working in silos. And then other people who are web developers can easily jump in and help when we sort of have a resource crunch. So we've been super happy with React Native. So that's just my thought on mobile, and that's it. So, thank you.